Let 2 plus 3x to the 12, I'm going to start writing this down. Let 2x plus 3 to the 12 equal, and then they start giving you this sigma notation. Okay. Oh, sorry, 2 plus 3x. I have the x in the wrong spot. Thank you. 2 plus 3x to the power of 12 equal to, and then they state an expansion here, but in terms of sigma notation, because I don't really want to say all 13 terms here when I know how predictable they will be. So I'm going to start at term 0, I'm going to go all the way up to 12, and then as we've seen before and we reviewed this morning, the binomial expansion will have sort of two components, but here they've sort of collapsed it down a little bit. So they call everything like these numbers here, right, which has the binomial coefficient in it, but also has these numbers kind of collapsed inside and simplified. They call all of that t of k, t subscript k, okay? And then there will be some power of x involved, okay? So when we talk about the greatest coefficient, what we're really interested in is this guy here. Okay, that's what we're interested in. Now, because they're starting us off easy, they have actually told us what t of k is. But if you have a look at it, let's write it down together because we're going to need it in a second. If you have a look at it, it's not that difficult to realize what that is, because when you're doing the normal general term, right, you have the binomial coefficient. There it is, right? And then you have some number of these and some number of these, okay? Well, if this is just the coefficient part, then I'm just ignoring the x. Does that make sense? I'll say that again. This is just the coefficient. So I'm just ignoring the pronumerals. I'm just looking at the 2 and the 3, and this guy here is also not a pronumeral, okay? So you can see the rest of it there. 2 times 12 to the power of 12 to the k, 12 minus k, and then there's a component with the 3's, okay? Full stop. Right, so this little puppy here, this is what we're interested in, okay? And we need to also, as you'll see later on, we need to know what this is in terms of factorial notation, because we're going to have to do some cancelling out here. Okay, so let me explain why. Part A. We begin by saying, write down expressions for this coefficient, k, the kth coefficient, and also the k plus 1th coefficient, the next one after this one, okay? Now you might say, what do you mean? That you've already written down an expression. It's like, well, yes, but in order to work with this thing, we want to have this and the next term interact with each other. I need to write this down all in terms of factorial. So that's the only part that needs extra work for this t sub k. So I'm going to say t sub k equals, all right, 12 choose k. It's a fraction. Right? What's on the top? Do you remember? What factorial? N factorial. In this case, the n is 12. So I'm just going to write 12 factorial. On the bottom, there's those 2 factorials that are going to combine. So there's going to be k factorial. And what's the other one? The one in the brackets. 12 minus k. Very good. Okay, so there's the 12 choose k there, the 12ck. And then the rest of it, you can't do very much to simplify it, right? There's going to be the 2's, however many you get, and then there will also be the 3's, however many you get, okay? So this is the kth coefficient right here. What about the next one, the k plus 1th coefficient? Well, all I need to do, you just have to be careful when you do it because it happens so many times, is you have to look at every time that k appears and make it advance 1. Okay, so if we have a look at the 12ck business, you've got 12 factorial still hanging out there on the top, but instead of k factorial, I'm going to have, was the next one over, right? So it'll be k plus 1 factorial, like so. Now, after that, I've still got some other stuff on the bottom here. This gets bigger by 1. This will get smaller by 1. Yeah? So this is not going to be 12 minus k factorial. It'll be 11 minus k. If you wanted, you don't have to write this. If you wanted, you could write this as 12 minus k plus 1 factorial. I would be okay with that. You're going to get the same answer, okay? But I'm going to just give a quick caution here. This is a really quick way to tie yourself in knots, right? Because there's so many brackets. This is kind of one of those places where it's easy to fall into death by algebra, and you just miss like a bracket or you miss an exclamation mark or something like that, and then you wonder why all of your working is wrong, okay? So that's the first thing I will say about that. The second thing is, I want you to know how factorials work, right? When you think about, like, say these guys here, okay? Each of the coefficients will be, what do we got? 4C0, 4C1, 4c, 2, and so on, right? Well, what are they in factorial notation? Well, the first one will be 4 factorial on 0 factorial 4 factorial, which is just 1, right? Do you remember this? NC0, no matter what n is, will give you cancel, cancel, 1, right? Which is why every end of Pascal's triangle is like that. When you have a look at the next one, this guy here, right? The top is still the same, 4 factorial, but what will happen to your denominator? Well, one of them will get bigger, and then the other one will get smaller. And you can see here, right? See how 4 factorial has 3 factorial inside it, right? There's going to be 4 times 3 times 2 times 1 here. Here's 3 times 2 times 1. They just cancel, which leaves you with 4, right? So if you can see what is happening rather than just crunching the algebra, you will have a better chance at success here, right? So this one gets bigger, this one gets smaller. I'm going to go directly to writing 11 minus k factorial, right? Same deal here, right? See how these powers, one of them will get bigger, you get more and more and more of them, and then one will get smaller. So I'm going to write here, this one is clearly the one that gets smaller. It starts at 12 and it's going to climb down. So I'm going to write that as 11 minus k. It's gotten 1 smaller. And then this guy over here, it gets 1 bigger. Okay. Right, so there is my expression for the kth coefficient and the k plus 1th coefficient.